It does sound like a busy place there.
Yeah.
So how's the new year treating you?
I'm sorry, what?
How's the new year treating you? What kind of math are we going to be doing tonight?
Well, let me, sorry. So,
slide it that way. All right, go. Or two. There you go. And just notice like this. I think what we're going to do is we're going to stand it up on the next step.
so do you still have my login for the Math Excel website?
Let's see. I think I probably do. I don't know if I had it stored on here or not. Let's see. I have a folder here. I guess I don't.
Okay, so... Alright, so it was the username, or are you on the website?
Yeah.
Okay. So the username was, in all lowercase, is DAWSON.
That it?
And then MD11.
MDLN, like that?
No, I'm sorry. MD, the number 11.
The number what?
11.
Oh, 11. Okay. Sorry. MD11.
Alrighty, and then password was, I think, TAN.
As in Tan? Tom, Apple, Nancy?
As in tan.
TAN.
And then V as in Victor. And OLD. D as in drum.
Okay. Is that it?
And then E. L. Sorry. LEMORT.
Alright, let's see if I got that right. If I didn't, I'll have you type it over here in the GoToMeeting. Yeah.
Okay.
You see over in the GoToMeeting window where you can type a message? Type in your password there.
Oh wait, I see. Okay.
In fact, I need why don't you type in your username and your password in that message window, and then I'll just copy and paste it.
Okay.
Okay.
Wait, sorry, that was the password.
Yeah, that's the. Oh, that's the password.
Yeah, and then username.
Yeah, go ahead and put the username in there also. I don't think I had the. Is that an? Oh, that is an 11. Yeah. Okay.
Yeah.
Oops. All right. Homework and tests.
I'm sorry, what?
Homework and tests in the upper left.
Not quite yet. First of all, I need to finish this thing in the Wednesday calendar slot. Just click on the little green circle. In the, up in the, underneath January, there's, Wednesday.
Okay.
And I've already started on this, but then there are questions that I just don't know how to do, and then there are ones I've done wrong.
Okay, shall we start on 3?
Yeah.
All right. When you have equations that are in standard format, like this is, where the x term comes and the y term is on the same side of the equation, and you have numbers on the other, they're particularly easy to solve by elimination. I would always choose to solve these by elimination if they're given to me in this format. Now, one thing you can always do with equations is to add them or subtract them.
So, like, you would add x to negative x, and then negative 5y to
Exactly.
positive
I would just
4y.
put a line under there and add those two things, which means adding all like terms. And notice what happens to the x. It gets eliminated. And that's one of the reasons they call it, by solving it by elimination, is you eliminate one of the variables. Okay, so this becomes 0x, or nothing. And what do we get when we add these two terms?
Negative y.
And when we add the two numbers,
Sorry, and that would be 2.
okay, so what's y equal to?
Negative 2.
Okay, so it doesn't matter which variable we solve first. Okay, the idea is to solve one of the variables, and once you get one of them solved, you can go back into either equation and solve for the other variable. Well,
Okay.
which equation is going to be the easiest to solve for x? Probably this first one.
Okay.
Why? And that's because it has a positive coefficient in front of it, as opposed to the second one, which has a negative coefficient. Not that we couldn't use either one. We could. But and you always can reduce mistakes by keeping stuff positive if you have a choice.
Okay.
Okay? So, let's plug in our solution for y into this equation 1, and what do I get?
So, I'm sorry, it'd be x minus...
Let's plug it in. Let's do it like this before we try to solve it. In other words, don't skip steps. Always do this step here. Don't try to solve that at one time. So now let's simplify this. What does that become?
X minus... negative 10.
Except it's two negatives. In other words, it's x minus a negative 10, which is the same as x plus 10.
Right.
Equals 11. Now the last step.
So it would be x equals 1.
Okay, so there's your two solutions. X equal 1. Do I need to put parentheses around these or anything? Or just comma? What do we get for, let's see, let's say it was 1 comma negative 2. Shall we see if that works?
Yeah.
Make sure you enclose your answer in parentheses. I seem to remember that we needed that. Alright. it say? Access not allowed.
Oh. That's probably because I have...
Oh, you have yours open also?
Yeah.
Why don't you close yours out? If we can only have one open, it makes more sense to have it open on my end.
Okay. Alrighty, I'm out.
Okay, now let's see. How do I get past this? Okay. Alright. Should I put in that answer again for 3? Because I don't think it's saved it.
I'm kind of wondering if the entire problem changed.
This is the same problem though, isn't it? Yeah. So 1 comma minus 2, right paren. And now we want to go to 4.
Yep.
Okay. What's the first thing you want to do on solving word problems?
You want to define the variables.
Exactly, yes. And that's what most people forget to do first. And in fact, the first thing you really should do on a word problem is read the last sentence first. Notice the last sentence always defines your variable for you. How much does an average movie ticket cost in each of these countries? Well, what do we have? 2 countries or 3 countries?
I think it's 2 countries, Japan and...
So let's let X be the ticket cost in Japan. And let's let Y be the ticket cost in Switzerland.
Alrighty.
And you don't always have to go to this much trouble to spell it out, but it's helpful sometimes to go to this much trouble. Sometimes if you don't spell it out precisely what it is, you can get mixed up in, are we talking the number of tickets or the price of the ticket? And so certainly until you get more adept at doing these type problems, I would suggest spelling it all out. Okay. Now, since we're talking systems of equations, we're almost certainly going to end up with 2 equations with these 2 variables. And then we're going to use whatever method we want to solve for those 2 variables. So what equation can we write from the second sentence?
Cost $80, 83 cents to buy 3 tickets in Japan, 2 tickets in Switzerland. So it will be 3x plus 2y equals 80.83.
Good. And the next sentence, what equation can we write?
3y plus 2x would cost 77.2 or 02.
Okay, so now we have enough information to solve these 2 systems of equations. Now, I really need to switch these 2 to get them both into standard format. In other words, I really want to, and sometimes it's helpful to number your equations, and I'll show you why. First of all, let's write this the way they said it, which was 3y plus 2x, but I'm going to reverse these 2. Correct? This was what it was?
Yes.
Okay. And I reverse them because I want the x's lined up and the y's lined up. Now, I can still solve these by elimination. It's just that I can't get a variable to go away immediately. In other words, by adding or subtracting them. Now, you're also allowed to subtract equations. In other words, if I have a plus b equals b, and I have a second equation, x plus y equals z, I can subtract those. So I can say a plus b minus x plus y equals c minus z. So I'm allowed to add or subtract equations. And sometimes subtraction's the best way to go because a variable will eliminate immediately if you subtract it. In that last problem we did, a variable went away immediately by adding it. Well, in this problem here, I can't get a variable to go away by adding or subtracting. Not yet. So what do I need to do? Remember, you can multiply any equation, the left side by the right side, and it doesn't change it. So what if we multiplied the top equation by 2 and the bottom equation by 3? Watch what happens.
Okay.
Top equation by 2 gives us what?
6x plus 4y.
Equals 161.66. Multiply the second equation by 3, gives us 6x plus 9y. You have a calculator handy? That can't be that hard to do. Let's see. 3 times 7's 21, so that's going to be 231.06, correct? Let's see. Yeah. Okay, now I have the same 2 equations I started with. It's just I've multiplied them by a number on each side, but that doesn't change the equation. It's still the same equation. Now, notice that I can subtract equation 1 from equation 2, and x will go away. And why do I do 1 from 2 instead of 2 from 1? I could do 2 from 1 also. It's just that when I do 2 from 1, I end up with a negative coefficient here and a negative coefficient here. So if I do 2 minus 1, the x's go away. I get 5y there, and I get $69.40 there. Now, I can solve for y, and I find out what the ticket cost is in Switzerland. Let me grab my calculator.
That's...
Do you have a number for that already?
No.
69.4 divided by 5 equals 1388. So y equals 1388. Now, how do I solve for x?
You would plug y into one of the equations and...
Pick one. Which one would be the best one to plug it into?
Probably the one at the very top, the 3x plus 2y.
Yeah, I don't think there's much difference between this one or this one. If I plug it in, what do I get? I get 3x plus 2 times 1388 equals 8083. So now I get 3x plus 2776 equals 8083. 3x equals 0.07. 80 minus 27 is 53. And I get x equals 53.07 divided by 3, 1769. And I'm comforted by the fact that that didn't have a bunch of digits after it.
Yeah.
In other words, we needed a ticket price to be in dollars and cents, not 17.68749.
Yeah, that would have been.
Yeah, that would have been deadly. If we'd have come up with something like that, I'd have known I did a math error somewhere. I might have done a math error somewhere anyway. These problems, there's so much arithmetic that you have to do that it's pretty easy to do a math error. But that's something you'd look for. You want to check the reasonableness of your solution, and you want to make sure that you come up with dollars and cents here and not 3 decimal places. Let's see. So, hold on. Got it so high up I can't grab the top. There it is. X was Japan, and X was 1769. Y was Switzerland, and Y was 1388.
And just a quick question about what you did, where you multiply the top equation by 2 and then the bottom one by 3. If you could do that, do you absolutely need to multiply both of them by one number, or by
in that case,
or at least?
Notice that I multiplied each of them by different numbers. I multiplied the top by 2. I multiplied the bottom by 3, different numbers. And the only reason I did was because I was trying to get the coefficients on one of the variables to be the same. And I can see that 6 is a common denominator between 2 and 3. So you can multiply them by positives, by negatives. Now, some people may have chosen to multiply one of these by a -2 or a -3. The only reason they would is because then you can solve it by adding the 2 equations, and you don't have to worry about subtracting the 2 equations. And again, if you can do problems by adding instead of subtracting, that's usually the better way to go. It's less likely to make a mistake. But in this case, I'm not sure that's necessarily true, because if I say multiply the top by 2 and multiply the bottom by -3, well, it's true. I put a negative there, and a negative there, and a negative there, and now I can add these 2 equations to get x to go away. But have I made it easier? Not really. I mean, I had to add 3 negatives here. So I haven't really made the problem any easier. I haven't really made it addition. And the same reason, one of the other reasons I did it is because I could see that if I made them both 6x, I was going to be able to subtract one of the equations from the other, leaving all positive coefficients. And that's a good thing. It makes doing the math easier. I was actually able to do most of this math in my head because of that.
Okay. All right, that helps.
Okay. Let's see. Should we do one more here?
Yeah.
Okay. Picked a good one, huh?
Yeah.
How are we going to graph this? What's the best way to graph it?
So I'm not entirely sure. I seem to remember hearing that you're supposed to treat the greater than or equal to sign like it's an equal, like just a regular equal sign?
Yeah. In other words, graph it as if it were an equation. And how would I do that? How would I go about graphing? In other words, let's start by saying, okay, we'll make it an equation and graph it. How would I graph that? There's a couple ways, actually. Most people would choose to put it into y equals mx plus b format. And then you probably can graph that, because when you have it in y equal mx plus b format, you can graph the y-intercept, because that's b, and the slope is m, so you just have to add the slope to that point, and you have your line. Let's do that. Let's solve this for y. And when you're going to put it into y equal mx plus b format, that's usually what you're going to do, is solve it for y. What's the first thing I need to do to solve this for y? Trying to get y all by itself on the left side of the equation.
Okay, so then you would add x.
Okay.
To it.
So I end up with 0.25y equals x minus 1.75. And I put the x in front because, remember, I'm trying to get to this format, y equal mx plus b. If I can get to this format, I know how to graph it. Okay, so now what?
Is that the correct format, or?
Well, not yet. We've still got this coefficient here. In other words, we've got to get rid of that coefficient. Get it into y equals something. If I divide both sides by 0.25, gets rid of that.
Oh, okay.
When you divide both sides by 0.25, you have to divide every single term you come across by 0.25. Okay, well, the 0.25s cancel, and now I've got y equals, well, this is not a particularly good way. Notice that 0.25 is a fourth. Okay, so what I really have here is this, and that changes. I flip the denominator and multiply, so I really have 4x. You see that? You see how that 0.25 turns into a 4x?
Yeah.
The other way I might consider doing it that makes it maybe a little bit more understandable, and this is the way I kind of wanted to do it, is instead of doing that, let's turn that 0.25 into a 1/4 immediately. Now, to solve for y, I have to multiply everything by 4. Well, that makes the problem a lot easier pretty instantaneously.
Okay.
Now, graphing that is pretty easy. Where do I start?
So the y-intercept will be -7.
Okay. And the slope?
And then the slope will be 4.
Right. So I'm going to get a graph that looks something like this. Let's pretend there's -7, and that's about a slope of 4. Okay?
Okay.
Now, if we go back to the original problem, this is an inequality, not an equation. So I need to be able to shade one side or the other of that line. In other words, what I really have here is y is greater than or equal to this.
Okay.
Now tell me which side of that line I need to shade.
On the upper half of the
Yeah, I look only to the y-axis. And I look to the y-axis and I find a point that is above that line. So that would fulfill my requirement. Well, I can tell which side that's on of the line. So that's what it looks like. Now, that's what I'm going to draw on here. If I can figure out how to use your tools.
It's
how do I do it?
if you hit that, so there's the toolbar to the side of the graph. You hit the thing right below the mouse.
This one right here, the line tool?
Yeah.
Okay. Click on the first point, which is -7. And click on the second point. Okay, if I have a slope of 4, I got to go up 4 and to the right 1. There's up 4, there's to the right 1. Okay, so there's my line. Now how do I shade one side or the other? With the bucket of paint?
Yeah.
So click on that and click over there. Save it.
Alrighty.
Check answer.
Okay.
Now, I left out one fairly important thing here. And that is that you can't quite treat this as an equation. I really should have solved it leaving the greater than or equal sign. And the reason is that if at any point in time you have to divide by -1, it turns that thing around. So you can't really solve it as an equation and then just change back to the greater than or equal to sign. I should have paid attention to that. Turned out that I never had to divide by -1 in this, so it didn't really matter. But it might. They might give you an equation where you do have a negative coefficient in front of the y, and then you would have to turn that around. If you ever have to divide or multiply by a negative number on an inequality, you change the direction of the inequality.
Okay.
Okay? All right, that looks like a good place to end.
Alright.
Okay? And let's see, I'll save it and just log out. Is there a log out button that I need to hit here, or
I think if you click on my name, it'll pop one up.
yeah.
Yeah, there it is.
All right. Sounds good, Matthew. I will talk to you next time.
Alright, thanks for your help.
Sure.